Welcome to our channel Learning Math. In this video, we're going to learn about lines and angles. Well, parallel lines are lines that have the same direction. Actually, if we produce any one of these two lines, they can never intersect. Now, before learning about the relation between lines and angles, let's remember together how to construct two parallel lines. First, let's have an example. If we want to perform a frame for a picture, first of all we put the first edge, then we put the second edge perpendicular to the first one. Now we use another edge that should be perpendicular to the second. If you note something here, these two opposite edges are then parallel to each other. They are perpendicular on the same edge. The same for the fourth one, we put it perpendicular to the third, then the two opposite edges here are also parallel. Here we have constructed a frame for a picture. Now let's construct together two parallel lines. As you see in the figure, we have here a straight line and a point through which we want to draw a line parallel to this one. First of all, we put our set square. We need to construct a perpendicular to this line, and then we will construct another perpendicular. The set square should be aligned to the straight line and exactly passing through this point. Now we can draw the perpendicular to this line, and then we're going to draw a perpendicular to it through this point. Now we get the set square again, we put it aligned to this perpendicular. It should be exactly aligned to the perpendicular. We move it a little, and as you see, the 90 degrees for the set square should be exactly at the given point. Now we can draw our perpendicular. Here we get, as you see, two parallel lines. Well, the symbol, the arrow symbol is for the two parallel lines. Now let's learn more about lines and angles. Actually, if we have two parallel lines that are cut by a transversal, the straight line that cuts two parallel lines is said to be a transversal. In this case, we can have alternating angles that are equal to each other. Well, what's the meaning of alternating angles and how to get them? Actually, the alternating angles form the shape Z. If we want to get them on our figure, we move on parallel, then transversal, and then the parallel. As you see, here is the shape Z. In this shape Z, we have two included angles that should be equal to each other. They have the same measure and they are said to be alternating angles. Why they are alternating angles? Because one of them is open towards the left and the other is open towards the right. Well, if you know something, if the first one has a measure 50 degrees, then the second one will have the same measure. Now these two angles are said to be alternating angles. Can we get other alternating angles? Sure. As you see in this figure, we have other two parallel lines cut by a transversal. Note how can we get this Z right now. We move parallel, transversal, and then parallel. Also here, the angles included in this Z are said to be equal as alternating angles. Well, when we have parallel lines cut by transversals, are we having only alternating angles? No, sure, we have also corresponding angles. The corresponding angles are the angles that are exactly facing each other. Well, if the first one has a measure, for example, 70 degrees, then the second one should have the same measure. Well, how to get the corresponding angles? Actually, we should first mark the angle between the first parallel line and the transversal. And then we move on the transversal to reach the second parallel line. Here, as you see in the figure, we have the two corresponding angles. Well, let's have an example together. As you see here, we have a triangle OMN. Here we have an exterior angle, which is ONX salient equals to 120 degrees. Now we need to calculate or find the measures of the missing angles in the figure. If you know something, here we have an angle 45 degrees. We have two parallel lines AB and MN. If you know something, can't we say that the angles OAB salient and OMN salient are equal as corresponding angles? They are exactly facing each other. Since we have parallel lines, then we can talk about alternating or corresponding angles. Also, we have this angle is 120 degrees, then its supplement is 60 degrees. Now we can say that also these two angles are corresponding angles. They are equal to each other, so the second one is 60 degrees. Now we can say that OBA salient is equal to the angle ONM salient equals 60 degrees. Something else, if you note here, let's use the laser pen to check it up. We can have Z shape. If we move on A, B, N, X, we move parallel, transversal, and then parallel. We can get a shape that here we have two angles that are alternating to each other. The measure of the first one is 120 degrees, then sure, the second angle should have the same measure, which is 120 degrees. Now we can say that the angles A, BN salient and the angle BNX salient are equal to 120 degrees. They are alternating angles. Well, if you note something, here we can write down. If you note something, here we can say that we have a triangle OAB, then the third angle, since we have the sum of the angles in a triangle is 180 degrees, now we can subtract from 180 degrees the other two angles, which are OAB salient and OBA salient. We get that this angle is 75 degrees. Something else, to calculate the angle AB salient, if you note something, we have here a straight line that should form a straight angle. We have OAM is a straight line. It forms a straight angle which is 180 degrees. Now if you think about the supplement of the angle OAB salient, which is 45 degrees, then the supplement will have the measure 135 degrees. Now we can say that the angle AB salient is equal to 180 degrees minus the angle OAB salient, which is 45 degrees, so it's equal to 135 degrees. Another example, as you see here, we have a triangle ABC. We have a point F on the side AC. We have the bisector to the angle AFH, which is FL. Well, bisector, it means that it will cut the angle into two equal parts, and we also have given that FL is parallel to HC. Well, now we need to find the nature of the triangle FHC. If we analyze the given, first of all we have parallel lines. We have LF is parallel to BC. How to analyze this given? Whenever we have parallel lines, we will have alternating angles that will form the shape Z. So we can say that the angles FH salient and FHC salient are equal to each other as alternating angles. Something else, we can also have corresponding angles. If you note something, since we have parallel lines, then we can say that the angles FL salient and FCH salient are equal to each other as corresponding angles. They are exactly facing each other. Since we have parallel lines, we can talk about the corresponding angles. Now we just write that. But also we have given that FL is the bisector of the angle AFH. So we can say that AFL salient is equal to LFH salient. Therefore, these four angles are all equal to each other. In particular, we can say that the angles FHC salient and FCH salient are equal to each other. Then they will be base angles for an isosceles triangle. Therefore, we can say that the triangle FHC is isosceles at F, since it has two base angles that are just proved equal to each other. Well, we have solved some examples about lines and angles. Now we're going to learn how to prove that two lines can be parallel to each other. Actually, we have learned that if we have two lines that are parallel to each other and cut by a transversal, then alternating and corresponding angles will be formed that are equal to each other. Now, exactly we will learn the contrary. If we have alternating angles or corresponding angles, then we will have parallel lines. So to prove that two lines are parallel, we can find either alternating angles that are equal or corresponding angles. If you note here, if we have two angles that form the shape Z and are equal to each other, then we can say that the two lines are parallel by alternating angles. Something else, if we have two angles that are equal and facing each other, then we can say that these two lines are equal by corresponding angles. Now let's have an example together. Before starting by this example, if you know something, we have in this given the two sides AF and AM in this triangle are indicated equal to each other. Then we will have an isosceles triangle. But we have given in this isosceles triangle an angle 60 degrees. Well, then we can say that this triangle will be equilateral. It's a rule. Why? Note that this angle is 60 degrees, but we have isosceles triangle, then the base angles will be equal to 60 degrees. But the sum of angles in a triangle is 180 degrees, then the third one will be also 60. Well, here we can deduce a rule. In any isosceles triangle that has an angle 60 degrees will become equilateral. So first of all, we have an equilateral triangle AMF. But note that we have given that the angle MAN is equal to 90 degrees. We have here 60 degrees. Then what remains for 90? Here we will have an angle 30 degrees. Well, something else. If you know something, we have the angle here FAM is 90 degrees minus 60 degrees is 30 degrees. We have the supplement to this angle, which is 60 degrees. It will be 120 degrees. Since we have a straight line that forms a straight angle 180 degrees, we can say that the angle AFN salient is equal to 180 degrees minus the angle MFA salient, which is 60 degrees, so it's 120 degrees. Well, also we have a triangle FAN. Can't we say that the sum of angles in a triangle is 180 degrees? Now what remains for the third angle? Isn't it 30 degrees? We can just write it. So it's 180 degrees minus the angles AFN salient and FAN salient. So it gives us 180 degrees minus 150 degrees, so it's 30 degrees. But as you see here, we have a coded property. We can say that the angles FNA salient and ANX salient, they are equal to each other as coded property. Then we can deduce that this angle is also 30 degrees. Now in the second part, we need to prove that the lines AF and NX are parallel to each other. To prove that two lines are parallel, it's enough to find either alternating or corresponding angles. How to find them? We move on the lines that are required to be proved parallel. As you see here, we mark these two lines. If we move on them parallel, transversal, parallel, we can get our Z. Sure, they are not parallel yet, we need to prove them. But note that we have angles included in this Z that are equal, 30 degrees and 30 degrees. We have just proved them. Now we can say that the angles FAN salient and ANX salient are equal to 30 degrees each, proved. Therefore, these two lines are parallel then by alternating angles. Now we can just write them. Well, is this everything to be learned about lines and angles? No. Actually, we can also prove that two lines are parallel if we prove them perpendicular on the same straight line. Note that these two angles are corresponding. We can say that these two lines are parallel by corresponding angles. Also here we can say that they are perpendicular on the same line, so they are parallel. This is a very important rule. Well, also if we have two lines that are parallel on the same straight line, then we can say that they are parallel to each other. Now what about lines and angles? As you see here, we have two lines parallel to each other. Also another two lines that are parallel to each other. Well, when we have parallel, then we will have alternating and corresponding angles. Note that here we have two corresponding angles that are equal to each other. Also, we will have another two corresponding angles that are equal to each other since we have parallel lines. Therefore, we can say that these two angles are equal to each other. Actually, if we have two angles that are parallel side by side, note that the first side of the first angle is parallel to the first side of the second. And also these two sides are parallel to each other. Therefore, we can say that these two angles are equal since they are parallel side by side. Finally, the last rule, as you see here, we have an angle. If you note something, we have drawn perpendicular on the first side of this angle. Then here we have drawn another perpendicular on the second side to this angle. Well, if you note something, we have a shape X that gives us two vertically opposite angles that are equal. Also, we have 90 degrees and 90 degrees. If we take these two triangles here, note that in the two triangles we have the sum of the angles is 180 degrees in each one of them. Well, we have the first angle in this triangle is equal to this angle, and here we have two angles equal to 90 degrees given. Now, can't we say that the third angles are equal to each other since the sum of angles in each triangle is 180 degrees? Well, now we can say that these two angles are equal. But what about these angles? Aren't they perpendicular side by side? By construction, we have drawn perpendicular to the first side, and then we have drawn perpendicular to the second side. We have formed another angle here. Well, it's a rule. We can say that two angles, if they are perpendicular side by side, then they will be equal to each other. Now, thank you for watching. If you enjoyed this video, please like, share and subscribe for our continuity for this channel to support you by more and more information. With a great appreciation for your support, thank you all.